Okay, ATS 114 TAs, I thought I'd just give you a quick tour of the lab about hurricanes. Again, most of this is just applying things that we've learned throughout the semester to hurricanes, rather than doing anything just too specific to hurricanes. On the question one where they're asking for drawing the winds around the hurricane, the trick here is for them to realize we're talking surface winds and in the northern hemisphere. So that means that it is rotating cyclonically. The winds are going to be kind of spiraling in around the hurricane, something like this. You want the winds to be counterclockwise. You want them to be mostly parallel to the isobars, but you do want them somewhat crossing towards the area of low pressure. So they should be spiraling in like that. On question two, I tried on the video for the students to watch to be a little bit more clear about what they're asking here. Sometimes students get hung up on this word periphery. If I go actually down here, I can show you on this diagram right here. Okay, so here's a cross-section of a hurricane. You guys all saw a diagram very much like this when you took ATS 113. And what they mean is way out away from the hurricane, there's large-scale sinking motion. I actually showed a little bit about that on the lecture that I made for the students. Now, sinking motion always involves warming and drying, because we're not changing the dew point, we're just warming the air parcel dry adiabatically. So by the time this air that is sinking through the depth of the troposphere near the periphery of the hurricane gets to the surface, it is very dry. And very dry air right over the ocean means that you're going to have a lot of evaporation. Why do we care about that in this class? Because we want to have a lot of evaporation off the surface. Remember, evaporation of water off the surface is fundamentally the source of heat for a hurricane. So that's where we're going with that. And then there are other questions about what factors affect the evaporation rate, like sea surface temperatures and wind speed and so on, which I think you guys are pretty comfortable with all that. Now, the book then goes into a section that's about Hurricane Sandy. And some of the things that it shows are way more complicated than we need them to be. I mean, like, for example, this plot's no big deal. We got basically a track over the course of, I don't know, a 4-day period or something like that, 5-day period. We have what the winds were. And the winds here are this curve, and they apply to this axis right here. And let's see, the book defines hurricane speed as 74 miles per hour. So like they want you to figure out, okay, so it was hurricane speed from, you know, let's say the 24th of October at 12Z to the 30th of October at 0Z or something like that. And you can do the same sort of thing for tropical storm strength winds and find out when it crossed the lines there. That's all we're looking for on that. That's not supposed to be too hard. Now, we're skipping questions 6 and 7. Question 8 has a vocabulary word in it that we sometimes get a little hung up on. It says here, assuming gradient flow, draw the winds around the high-pressure cell on these particular dates. The word here is gradient wind. That's a problem. Don't get too hung up on the word gradient. I think I over-explained this in the video for the students. Gradient winds are just winds that are parallel to the isobars when the isobars aren't straight. Okay, so something like, you know, like what I'm drawing right here, okay? I mean, when we learned earlier about geostrophic wind earlier in the semester, strictly speaking, geostrophic wind only works if the isobars are straight lines rather than curves. Well, in the real life, they're almost always actually somewhat curved, and the right word for that is gradient wind. The textbook actually makes a big federal case out of this whole difference, but actually the difference is, I mean, within like a few percentage points. We are not going to get bogged down in the difference between gradient wind and geostrophic wind. Just watch out for that vocabulary word in this particular lab activity. I like these questions actually, like starting on number 11. Let's see here. What page are we on here? 175. There we are. Oops, one more page. There we are. Okay, so there's a set of these kind of forecasts here where they are showing at any given time they were running, oh, I don't know what does it look like, 1, 2, 3, 4, 5 models, computer programs that were simulating where the hurricane was going to go. The right word for that, by the way, when you run a set of models to see if you can, you know, get some sense of like the uncertainty, is an ensemble. There's an ensemble of models here, in this case 5, to kind of give you a sense of like, you know, how variable is the forecast here, rather than just having a single computer forecast of what the storm is doing. And what the book, I don't even think they uses the word ensemble, but they certainly do in the lecture. So what the book wants you to notice is, for example, look at how well forecasted or at least how tight the ensemble was at this particular time, where the difference between the easternmost and westernmost track of the 5 models is only maybe, I don't know, 100 miles or something. You have to use the scale on there to figure out. Whereas there's other times like this where there was great uncertainty in the forecast of this storm, which I think is Katrina. Yes, it is Katrina. Okay, that's where they're going here. They want them to get the sense of like how hurricane forecasting is done, and like trends in the predictions of the path and stuff like that, and forecast errors and so on. And again, check that rubric. There's a handful of questions along the way here that get skipped. We're definitely not doing 13. We're definitely not doing 14. I think actually we stop at, I don't think we do 16 at all. So I think 15 is the last one. But check the rubric just to be sure. Okay. So there's really not that much to this activity other than kind of getting a sense of the challenges associated with forecasting these systems and so on, and how variable the forecasts are and things like that. Okay, I think that's everything that you need. I wish you the best of luck, and if you have any questions, you can always contact me during the lab.